Let's have a look at another network flow example, and this one is a far more obviously complicated version of example number one. But we're doing basically the same thing, except it's just there's a lot more paths to consider. So let's read the question first. So consider the following directed network representing traffic flow, and here's the network there, and the numbers, basic cars per minute on these particular roads, and determine the flow capacity of this network. So that's part A. And part B, we're going to redraw this network showing the traffic flow along each road in order to achieve maximum flow. What that's going to mean is that we need to look at the roads that have excess capacity and basically change the number to reflect the exact capacity needed for each of these roads. Okay, so let's start off then. And what I've done is that I've printed this up on a sheet of paper, and I've got part of a whiteboard here. So what we're going to do first is we're going to consider some of the more obvious paths first, from source to sink, and then consider which edge along those paths is the minimum or the lowest value. Okay, and then we're just going to continue on that way and keep subtracting away from the capacities of these edges until we end up basically saturating the network. So let's have a look at maybe an obvious path. So I'm going to basically account for these paths here. So we have path SAT. Okay, so we've got SAT, and the minimum, you look for the minimum number. Okay, so the minimum number is 270. Okay, so that path can carry 270 cars per minute. Okay, now a pencil is very handy. Okay, pencil and an eraser, they're the two things that you need, and of course a calculator depending on the values that we're given. So all right, you'll need one of these. Okay, and obviously one of these. All right, so SAT 270, what we're going to do is we're going to subtract 270 from each of these numbers. Okay, and so we end up then with 30 here for this path AT. Okay, that means now we can no longer use SA. Okay, so that's now basically saturated. Okay, let's try and identify another path. So we could use maybe another, just think of an obvious one, maybe just straight across. So S, B, C, D, T. Okay. There's many ways of doing this, and you don't have to use these paths in this particular order. Just whatever's more obvious to you. So S, B, C, D, T. Again, the smallest number is 230. Okay, so that means that path can contribute 230 cars per minute from source to sink. So let's write that down. Okay, so hopefully you can see that okay. Yep, I can see that on my camera. Right, so we're going to subtract 230 from each of these edges along this path. Okay, so notice that every time you do that, one of these edges will become 0. That means that we've saturated it. It's there's no more spare capacity in those edges, okay, or on those roads. So now we're going to subtract 230 from each one. So that's going to be 90. Okay, so this one will be 140. Okay, and this one will be 480. Okay, so all right. So we can no longer use path BC. That's now saturated. We cannot. That's no longer can no longer be considered. All right. Let's have a look at another. Maybe another sort of obvious path is SEF DT. Okay, so SEF DT. Yep. And let's consider the smallest value. So the smallest value is 260. Okay, so what we're going to do, that means that's the obstruction, that's the bottleneck. All right, we're going to subtract 260 from the remaining roads on that path. Okay, so that's going to be now 0. So that road is saturated. 440. Right, so that one now is 180. Okay. 270. Okay. 480 minus 260. Okay, notice now that we no longer use the 710, we're using the 480. Minus 260 is 220. Okay, so we still have some capacity, maybe have some capacity left between S and T. Can we identify another path somehow? So we can't use SA, we can't use BC. EF is now gone. Is there another way to get from S to T? Okay, so we could go SB, A, C, DT, sort of a complicated path there, or we can go SE, C, DT. Maybe we'll do that one. Okay, SE, C, D, and T. All right. Right, let's walk along this path or drive along this path and see which is the lowest number. In fact, we've got 180 there, 180 there, 140 there, 220. So 140 is the bottleneck. Okay, so we're going to saturate that one. That's now to capacity, and that now is 0. Okay, so that path now can no longer be considered, and we're going to subtract basically 140 from all these other numbers, all these other capacities there. So that's now 40. Okay, that one there is now 40 as well. Okay, and that's 0 there, and what else have we got? 220, so that's 80. Okay, so okay. All right, now the question is there any other way to go from S to T? Can we think of another way? We can no longer use this edge here. We've got 40 here, 40 there, but we can't go here anymore. So these two roads, SC and EC, are no longer available or can no longer be used. But we can't go S. Can we go S, B, A, C? No. Oh, hang on. We can go S, B, A, T. Okay, so it's very, very important that we consider every option. S, B, A, T. Yep. So we've got a capacity of 90 there. B, we've got 290. So we haven't even used that one, that particular road yet. We've got an AT is 30. So we've only got 30 left on that path. Okay, so we're going to subtract 30 from that. So that's gone. Okay, AT is saturated. We used up all that capacity. Okay, and we're going to just subtract 30 from each one. So that's now 60. And 290 minus 30 is 260. Okay, so I might just... okay, so you'd agree that a good sharp pencil is very important. Okay, because like I said, you may make a mistake here. So it's very easy to fix. Okay, and I think that's it. That's all the paths considered. So adding all those up, so 270 plus 230 plus 260 plus 140 plus 30, we got a capacity of 930. Okay, so that's the flow capacity of this particular network. What I'll do is I'll do part B as a second video because it's, I don't want the videos to be too long. And what we're going to do is we're going to redraw the network so that we're not going to have any spare capacity.